All right, in this podcast, we're going to talk about all the other titration curves that we haven't already covered. So we've already covered strong acid, strong base, and then we've covered a weak acid, strong base titration. Now let's look at a weak base, strong acid titration. So basically, it's the exact opposite of the weak acid, strong base. It's pretty much the exact same thing as far as you start with a buffer region, but the curve just flipped. So it starts at a higher pH and ends at a lower pH. The calculations are going to be the same as far as before, after, at equivalence point, excess, all of that. Okay? All right. Another one that we need to look at. Okay, here. Whoop. All right, that was still the weak base, strong acid, and just notice that the equivalence is below 7 because with a weak base, strong acid, the acid overrides and you end up with an acidic salt, and that's why your pH at equivalence is below 7. All right, now polyprotic acids are the ones that have multiple H's that they can give off, have these curves that have basically two titration curves put together. So you have one for the first H and one for the second H. So basically you have two of everything. You have two equivalence points, two half equivalence points, because you have two Kas, which means you also have two pKas, okay? So all right, and here we have an acid that has 3 hydrogens to give away, so now it's like 3 titration curves together. The yellow ones are going to be your half equivalents, and the blue dots represent your equivalence points. And you see there's a first, a second, and a third equivalence point for every H that comes off of that acid. Now, if you wanted to talk about a base that could accept more than one hydrogen ion, such as Na2CO3, so when you're looking at that, you're basically talking about the CO3 2 minus, okay, so he can accept 2 hydrogen ions. And you see here, you have a first equivalence and then a second equivalence because you basically have 2 titration curves together just in the opposite manner. Okay, so understand that titration curves can tell you a lot about what you're looking for. Make sure you pay attention to your axes to see if you're looking at moles or if you're looking at, a lot of times it's volume of titrant added, okay? And as long as you pay attention to these things, you should be able to notice where you have a half equivalence point, which is the flattest part of the curve, and a full equivalence point, which is going to be the steepest part of the curve, okay? And depending on how many you have, you should be able to tell how many either hydrogen ions are being accepted or removed during that process.